Hello and welcome to this video. In this video we will study the separate chaining of hashing, that how we create a separate chaining implementation of hashing. But first of all, a special welcome to new people on my channel. If you are new to the channel, please subscribe to the channel and press the bell icon so that you can get notified about the upcoming videos on data structures. Also, if you have not watched the theory part of hashing, then you should browse the previous videos on playlist and watch those. Once you are familiar with theory, you can come and look at this implementation. So as we have discussed, suppose we have a mod function. Consider we have a function mod, say 100. I have taken 97 because it's a prime number. Now suppose we initialize this, then there'll be 97 empty boxes like this initialized with null in the beginning. So this would be like this 97 times, and we will have empty lists. Now suppose we have mod 97 and we insert 1, then 1 will go here. And suppose we insert 11 here, then 11 will go here, because sorry, not mod 97, right? So yeah, 11 will go there, 11 will go here, because no, 11 will go in 11th box. So if you insert say 98, then 98 would go here. If you insert 97 plus 98, 195, 195 would go here. If you insert 11, it will go in the 11th box. If you insert 2, it will go in the second box. 99 will go in this, and 196 will go in this. So this is the implementation of hashing. So let's get familiar with the code. This is one file. So I have defined max size as 100. That is the maximum number of size. I think I should define it as 97. Yeah. Max size is 97. Mod is 97. We have an element structure which contains a value and a pointer to next. We have a hash which contains a list of chains. We have a size for the size of the hash. Now in the main function, I initialize the hash. To initialize the hash, what we do is we allocate memory for hash. We set the size as max size. Then we allocate for those many number of elements for the chain, and we set initial pointer to be null. Now once we initialize, we have put function. In put function, what we do is we calculate the mod of the given value. Once mod is calculated, we try to search for that value in the linked list of chains. Okay, if it is found, then we return, otherwise we insert the value. Now this insertion is not the way it is described earlier. The insertion would be like, initially it is null, so an element comes, let's say 1 comes, 1 will get inserted at the beginning. Then suppose 98 comes, 98 will get inserted before it. Okay, so that is how insertion will happen. This is done so that we have faster insertion time, order 1 at the beginning of head. Otherwise we will have to if you append at the end, then it will be on. Now after that, we have a contains function. We supply the hash and the value, we calculate the mod, and we search for the element in the mod, and we compare the value with the supplied value. If it is found, it is return true, otherwise it's false. So let's see the execution. I have put in 56, 36, 22, 67, 85, 9, 19, 29. So all these will go at their own value in their own cells. There will be no separate chaining with this input. We will add more. So after that, I have tried to find these elements, and apart from 58, all others should be found. So let's compile and see this in a run. So we see that the second value is not found, all others are found. The second value is 58. Now let's insert some more values like 98 we want to insert. 98 and then 195, and we want to search those. So these will cause collision. 98 will collide with 1 and 195 will also collide with 1. So let's see if we can find 198 and 195. We find 198 and 195. So let's see if we can find after collision. So yes, we can find them after the collision also. So this is how you implement separate hashing in separate chaining in hash data structure. It is not very useful because the search time is quite bad. If there is a long chain, then search time will worsen in terms of collision. So if this data structure, if the input data is skewed, search time can be quite bad. Okay, so it is typically not used in implementation. Open addressing is far more useful. Open chaining is far more useful. So in the next video, I will introduce open chaining or close addressing. So this was a very simple, dead simple program, and there is not much to it. So I will end this video here, and I hope that you have found this video useful and informative. Please like the video and share it on social media as much as you can, and make use of the comment box. If you prefer, if you subscribe to the channel or like the video, then it motivates me to make more video. Even if you only watch the video and do not subscribe or share, even then it motivates me. The higher number of views motivate me. But if you can help me, then it will be a lot of help. So I'll be grateful for that. So thanks a lot for watching. Happy programming.